Hello, today is about the hidden math of AI confidence. We have different tools to increase accuracy. The AI agents have limitation in accuracy, so they hallucinate. They give us sometimes really wrong results. We have complex tasks and they need to be decomposed and specialized. Key to the system design understanding is to think in probabilities, to understand the probability, which is a very base of the LLM. We have to look in the architecture, because this can impact the outcome very dramatically. And just as a disclaimer, the number that I show, they are simplified. They're not the real LLM numbers. It also depends on that LLM, right? And they're also better in one area than in another area, so it's hard to tell the exact numbers. The first pattern I wanted to show is the multi-agent pattern. When I want to book a flight, for example, I can use a booking agent which has a flight selection agent and also a calendar agent, which help me to book my flight. But when I have these multiple agents that process the same input independently and in a sequential way, they operate without the knowledge of the others. The result is then aggregated, so I should get a correct flight for my example. Often the LLMs are based on the same training data, or I use the same LLM for all those three, in this case, all those three agents, and so they are not fully independent. But if they would be independent, then the accuracy would just be multiplied. In this case, I would like to search for the next Tuesday for a flight. So I use the calendar agent and the flight agent. And when I assume that both have an accuracy of 80% only, it would result in only 64% accuracy. So this is quite a bad result. We do not want so low probability, so we have to improve it. An agent work with voting and retry and other mechanisms. And you see here in the pie charts below that when there is just one agent with 80% involved, so we have accuracy of 80%. But when there are two in a row, it goes down to 64%, and with three it goes down to 50%. So imagine if you have 100 agents working in parallel, the result most probably is not very satisfying. So we need some tools or some algorithms to improve it. And one possibility is the voting agent pattern. So with this pattern, the output of different agents is voted, and the majority will win. And only when the majority is simultaneously wrong, we would get a wrong result. In the example here, we have our three agents for the flight book, and the probability when all of them have 80%, for all three of them is only about 50%. And when there are only two of the three are correct, we have a probability of about 38%. So in total, just as numbers tells it, we would get a probability of 90%. So only in 10% of the cases it would be wrong. LLM Council AI uses a similar voting functionality. It has also some weights, but I would not like to go into detail. Another pattern is the retry pattern. So we retry. It's also called reflection or self-refine or critic-actor pattern. When we have an input, our LLM generates an output. And then the critic observer analyzes the output, and when it finds an issue, it identifies the issue, corrects or tries to fix it, and then will update the output accordingly, and then goes for a loop and will try it again and again to increase the accuracy or the correctness of the final output, which is then returned at least after a maximum number of iterations. Why does it work? Because we break down a complex task into small steps, and this observer correctness tool is specialized in fixing errors, and with these small steps we can avoid error accumulation. So before an error would grow very big, we reduce it already on each iteration. So we have also separations of concerns. The LLM can reflect on its own mistakes because it has the conversation in memory, and it has iterative improvement, and it converges to a higher quality output. This can be seen quite similar to code review in software development. So there's one developer who produces code, and then another one will review it to increase the quality and the correctness of the code. Another pattern is the limited selection pattern. So in this example, we pick 3 and get a higher score than when we would generate it from scratch. So we tell the agent to choose from a predefined list of options. it can also be called enums, and convert the possibility of open-ended answers to just multiple choice. This improves reliability and also it reduces the output space complexity. And this is used for tool selection. So when you have about 20 tools, the LLM tries to select the correct tool, but it only needs to choose one out of 20 and not one out of 1 billion. When I would have an open-ended question, it would be, what is the capital of Austria? But when I ask a multiple choice question, I can ask Vienna, New York, Paris, what is the capital of Austria? And with these three options, if you just choose one randomly, you have already 33% correctness. It helps also in comparison various construction. So it only needs to compare against Vienna, and it's easier than to generate the word Vienna or the correct answer. Also, it helps in partial elimination. So when it knows that one option like New York is not in Austria, so it cannot be the capital of Austria, it can just avoid it. It's not part of the solution for the response. And also there is exact match noise, which means that, for example, Vienna, Austria could be a wrong answer because it's only the word Vienna, so this can be marked as incorrect and be removed. When you have only three options, of course, it will be only Vienna. So the key takeaways are building agent systems which are very correct is quite challenging, and you will be always below 100% of accuracy. And just adding more agents and more agents and more agents will not help. You need an architecture which matters, and it helps to increase this accuracy. Voting or retry loops, they help as shown with the numbers, right? So I hope this is quite helpful for you. And also the limited selection dramatically improves accuracy. So I hope this was interesting. Thank you for watching, and if you need a company training for Kafka or Kubernetes, just contact me on LinkedIn. Bye, thank you.